So for example, if I want to create a wafer map, I just need to click here. And it will load you the example data set we prepared for this demo. For those audience who are not very familiar with the wafer map use case, let me quickly explain the data columns here. So we have the die X, die Y. Those are the values represent the spatial coordinates of each die on the wafer. And also we have the lot column. That is a batch of wafers processed together through the same production steps. And also we have the wafer column that identifies a specific wafer number within the lot. And usually they can number from 1 to 25, depends on how many wafers in one slot. And this is the bin column. It usually represents the test result category for each die. For example, bin 1 could represent it passed, it's a good die, but bin 2 or 3, 4 other values could represent the different reasons for the failures. And values could be any other values, like when you measure from the beam, like it could be the temperature or pressure or some test values. So comes back to the front end. In this guide, we just follow the instructions here. We can find these actions called create wafer map. And I just click this run button and make sure I'm selecting this example wafer data. Just need to match the exact columns this action requires. And make sure, since I'm selecting the bin column, remember just now I explained this is the categorical data column. Then I click run button, and I will get this wafer map immediately on my dashboard. And this is not just some image, because it's highly interactive, that you can still drill down, zoom in, zoom out, select multiple wafers to do the further analytics. But I would say this is the very basic step to prepare your data, to convert the data to the wafer maps. And I think this tab shows you the example output. All right, let me show you the other example. I need to close this one first. Yeah, we have another demo. It's called wafer zoom analysis. In Momita's presentation just now, she also pictured how Renesas is doing zoom analytics. So it is a very useful analytics tool and method to further drill down and analyze the performance by different zooms. So we have a similar example data with XY lot wafer bin. And now I want to create some zooms on the wafer map. Let me follow this instruction. I have to create the zoom values first. And similarly, I need to define the X, Y, and the number of the radial zoom and the angular zoom. And I click run. So after I run this first action, I will get two columns that split my records by the zoom. And I have very specific number to represent the zoom, the different zoom values. Okay, so the next step, I want to create some visualizations. We prepared another action here, analyze zoom profile. Okay, I have to make sure this is the right data set, this is the right X, Y column, and the bin value. Okay, but here we have to select some columns because we need the lot ID. Same, like we have to let the action know what columns represent my zoom numbers. Okay, and I click the run button. Yeah, so after that, I will get another tab that showcases you the values by different zoom. So those numbers will represent the zoom we created just now. And just describe you one example, one quick insight we can learn from here. So this green color, like bin 4, it could represent some good values, and we see the high values at the beginning. And we have another group of red color line trapped here. Then we see some hikes in around this area. So for the engineers, they can go further to analyze where those zones are located on my wafer map, and they can try to understand the pattern. And if, let's say, this green color represents some good, but the red color represents some bad result, then the engineers can quickly understand what is the reason. It could come from which specific zone of the wafer map. So that's how we can support the zone analytics from using